Problem number 9. The homogeneous bar ABCD shown in the figure is supported by a cable that runs from A to B around a smooth peg at E, a vertical cable at C, and a smooth inclined surface at D. Determine the mass of the heaviest bar that can be supported if the stress in each cable is limited to 100 megapascal. The area of the cable AB is 250 mm square and that of the cable at C is 300 mm square. So, first thing na gagawin natin dito is to draw the free body diagram. So, if we are going to cut this cable here and we will expose this tension AB, and since itong cable na to ay nagra-run hanggang dito, so since this is a smooth peg here and the same tension yung nagra-run sa entire cable, so meaning here at point B, the same tension AB yung makikita natin dito. And here, if we are going to cut this, may expose ngayon yung tension at point C. So, the weight of the bar must be acting at the midspan. So, since we have here the total of 6 meters, meaning 3 meters sa left and 3 meters sa right. And we have here 1 meter and 1 meter. So, that would be 3 meters on the left side of W and 3 meters on the right side of W. Now, for the reaction at point D, since this is a smooth inclined surface, meaning we only have one reaction at point D, the reaction at point D must be perpendicular at the point of contact. No? So, hindi siya always vertical. It should be perpendicular at the point of contact. So, in order for us to determine this angle here, kung titingnan natin, this is 50 degrees here. So, meaning, itong part na to is 40 degrees. So, since this is 90 degrees, so meaning this is 50 degree also. So, if we have here the reaction, RD, that is 50 degrees from the vertical. Okay, so first thing na gagawin natin dito is to summate forces horizontal is equal to 0. So, summation of forces horizontal is equal to 0, taking the direction to the right as positive. So, first, establish muna natin yung mga components ng forces. Here, we have the vertical component, the TABY, and here we have the horizontal component, which is the TABX. And CRD has two components since it is directed to quadrant 2, so it has a vertical upward and horizontal to the left na components. So this is the RD, this is the RD, so this is the RDY, and this is the RDX. Now for the horizontal forces, as you can see here, only the horizontal component of this TAB here and the horizontal component of RD yung makikita natin. So we have yung horizontal component ng TAB dito is directed to the right, so it's positive TABX. And the horizontal component of RD is directed to the left, so it's negative. RDX is equal to 0. So, this is adjacent side of the angle 30. So, we have here TAB adjacent, so that's CA, so it's cosine 30 degrees. Minus RD, we have here, if this is 50, this RDX here is also this horizontal component here, which is opposite of the 50 degrees. So opposite it's so meaning this is sine of 50 is equal to 0. And if we are going to express this in terms of RD, so we have here RD is equal to TAB cosine 30 over sine of 50 degrees. And this is our equation 1. So next thing na gagawin natin is to summate forces vertical. So we have here summation of forces vertical is equal to 0, taking the upper direction as positive. So ang mga vertical components natin ay yung TABY. We have the TAB here, W, the TC, and the vertical component of RD. So we have TABY, it's positive because it's directed upward. The TAB here is also directed upward, so it's positive TAB. W is directed downward, so it's negative W. TC here is directed upward, so we have positive TC. And the RDY here is directed upward, so plus RDY is equal to 0. So for the TABY, since this vertical component here is the TABY, it's opposite of the 30 degrees. So we have here TAB, opposite is sine, so we have sine of 30 plus TAB minus W plus TC. And we have RD here, it's adjacent side of 50 degrees, so it's cosine. So we have RD cosine of 50 is equal to 0. Now, since from our equation 1, RD is equal to TAB cosine 30 over sine 50, so we substitute that here, and we would have TAB sine 30 plus TAB minus W plus TC plus TAB cosine 30 over sine 50 multiplied by cosine 50 is equal to 0. Now, pagsasamahin natin lahat ng may TAB, ito yon, ito, at ito yung ating last term sa left side ng equation. So we have here for the first term, it's sine of 30. Second term, we have here 1. And the last term para sa left side equation, that's cosine 30 multiplied by cosine 50 over sine of 50. This is equal to 2.2267. So we have here 2.2267 TAB plus TC, equate natin siya kay W. Now, here, TC is equal to W minus 2.2267 TAB. And this is our equation 2. Now, if we are going to summate moment at point D is equal to 0, taking the clockwise rotation as positive, yung magkikreate ng moment ay yung vertical component ni TAB. Ito, si TABX ay tatama sa point D, so hindi siya magkikreate ng moment. Ito ay magkikreate ng moment. This would create a moment. This would create a moment. So we have here the TABY multiplied by the perpendicular distance to point D, so it's 2 plus 1 plus 1 plus 2, that's 6. And this TAB here will create also a clockwise moment. Multiplied by the perpendicular distance, it's 2 plus 2, so that's 4. And this W will create a counterclockwise moment, so it's negative W. Multiplied by the perpendicular distance, it's 2 plus 1, so that's 3. And this TC here will create a clockwise rotation, so it's positive TC multiplied by the perpendicular distance, which is 2 meters. And this is equal to 0. Now, si TABY here is the opposite of the 30 degrees, which is also this one, so that's TAB sine 30. So we have TAB sine 30. Si 6 ilipat ko na lang sa unahan, plus 4 TAB here minus 3W plus the TC from our equation 2, that is equal to, so C2 here multiplied by TC, so it's W minus 2.2267 TAB is equal to 0. Now, pagsasamahin natin lahat na may TAB, ito, at ito. So, we have here 6 sine of 30 plus 4 plus 2 times negative 2.2267, and that would give us 2.5466. So this is 2.5466 TAB. And for the W, since you can see here, this is negative 3 plus 2, so it's negative 1, and kung ililipat natin sa right side ng equation, and that would give us positive 1. Now, if we are going to express the TAB in terms of W, we have the TAB is equal to, so that would be 1 divided by 2.5466, and we have here 0.3927. So this is equal to 0.3927 of W. And this is our equation 3. Now, if we are going to substitute equation 3 to equation 2, so we have here, substitute equation 3 to equation 2, then we have TC is equal to W minus 2.2267 of TAB, so that's 0.3927 W. So we have here TC is equal to, so it's 1 minus 2.2267 multiplied by 0.3927, and that is equal to 0.1256. So we have here 0.1256 W, and this is our equation 4. So the problem says that the stress in each cable is limited to 100 megapascal, so the stress is limited to 100 megapascal. And for the area of the cable AB, that is equal to 250 mm square, and the area of the cable at C is equal to 300 mm square. Since we are asked to compute for the heaviest bar that can be supported, so first we will base on cable AB. And for cable AB, so we have here stress in cable AB is equal to the force AB over the area of AB. So we have here stress, since all stress is limited to 100 megapascal, so this is 100 megapascal. The tension AB, yung tension AB natin, that is equal to, from our equation 2, that is 0.3927 W, and the area of AB is 250 mm square, so we have here 250 mm square. So solving for the value of W, we have 100 is equal to 0.3927x over 250. So solving for the value of x, shift solve equals, and we have here 63,661.83 Newton. So why Newton? Kasi we have here the stress in megapascal and the area in mm square, so yung lalabas na force is in Newton. So this is 63,661.83 Newton. Now, if we are going to base on the cable C, we have here the stress at cable C is equal to the force at cable C over the area of cable C. So since the stress is limited to 100 megapascal and the TC from our equation 4, that is equal to 0.1256 W over area of cable C, that is 300 mm square. So solving for the value of W, so we have here 100 is equal to 0.1256 W, palitan natin ng X, over 300. Shift solve equals, and that would give us 238,853.5 Newton. So this is 238,853.5 Newton. Now, if we are going to determine which of the two weights na na-compute natin yung safe, so always the safe load is the lowest value. So meaning the safe value of W is equal to 63,661.83 Newton. And that W here is the weight, no? Since we are asked to find the mass, meaning the mass must be in kilogram, or since masyadong malaki yung sagot natin, we will express that in megagram. So nakadepende pa rin to sa choices na binigay sa problem. So we know that the weight is equal to mass multiplied by the gravitational acceleration constant. So we have here 63,661.83 Newton is equal to mass multiplied by 9.81 meter per second square gravitational acceleration constant, and that mass is equal to 63,661.83 is equal to 9.81 of m. So shift solve equals, and that's 6,489.48 kilogram. 6,489.48 kilogram. Now if we are going to express this in megagram, we will just divide this by 1000, and that would give us 6.49 megagram. And this is our answer.